Hi, and welcome to this week's edition of Gruber Wired Hour. My name is Mark Beach.
I'm Mark Schaffner. I'm joining in.
Welcome.
Good morning for everybody.
Yeah,
Hi, Mark.
Normally my normal partner isn't here today, and just as a little tribute, just to let him know we're thinking about him, we thought we'd just throw up a little photo of John and say, hope you're doing well, and we look forward to you joining us next week, John.
Looking forward to having John back, and it's a real privilege to be able to sit here again and take John's fill John's big shoes, as it were.
There you go. Well, so this week we're going to talk a little bit about smart tech, and I thought that a great place to start would be to discuss, the history of tech and where did it all come from, and then we'll roll from there into current and future applications of tech. So, how did we get here? And if you want to throw up image number 1A.
There's been a lot of history we've gone through, hasn't there?
Yes, absolutely.
That's our first computer.
That's it right there. And, so we're talking about 2700 BC, the abacus, and it is, I don't know how to use one. Do you?
I don't. I'm not quite that old.
I haven't learned that skill. Some people still use, you can buy them on eBay.
You can buy them on eBay.
Amazon.
You can use them.
Yep.
There are people that know how to use these things, and they're fast too.
Yeah, they used to watch them and they go, okay, well, and that's where things start. The desire to simplify a process, especially counting. I mean, it's so basic in our lives. We count everything,
right?
And whether you want to call it counting, computing, whatever. This is a very simple way of counting and making things easy to get to the result, because it's point A to point B type thing. So you're always trying to solve a problem, trying to get to where we're going, right?
Right. I mean, this may be analog, but it is a computer.
Exactly.
A computation device.
Yes.
Or any device, no matter how old it is, that helps you to arrive at answers with numbers is going to be a computer.
That's great. All right. And so then if we're going to bring up image 2, we will see an image of what a German mathematician and astronomer built. We would consider this to be the actual first calculator. And this is William Schickard, right? And so these dials kind of worked in sequence, and they used that device to count. Look at that. I mean, there's some engineering going on right there.
There is some incredible engineering going on, and you look at what people came up with, considering what they had to work with. And this is 250 years before the Industrial Revolution. This is all handcrafted stuff.
1623. When you think about it, I mean, today's computer tech is built on a history of tech, so it's one thing leading to another thing. But when you do the first thing that nobody's ever done before, when you start developing something out of thin air, right?
Yeah.
As a concept, then I mean, you just have to marvel at the genius behind things like that. So when we go to image 2, we look at Pascal's version of a calculator or an adding machine, and he could mass produce these. So it was in 1642, and he could. It's image 2, I think, right?
This is image 2. You want the next one?
That's image 3. So there was image 1A, which is the abacus. Image 1 is and then image 2 is the Pascal.
So this one is labeled image 2. I can find the other one.
Okay, I'm sorry. This one is the Pascal one. And that one is something different. That's okay. We can just pick up there.
We'll pick up there. That's the one from Gottfried Wilhelm.
Right. So this one is called the step reckoner. And what that does it was the first built in 1673, and it did multiplication by repeated addition. So it could do multiplication on this device. Which,
Well, do you remember growing up as a kid? You know, you count your fives: 5, 10, 15, 20, 25. Oh, 5 times 5 is 25.
right, exactly. And so, okay, sorry. Great. And then we get into so we're going to get into some more interesting stuff here pretty soon, I promise. You know, this for the Jacquard loom. Now, this was the first thing that really kind of caught my attention, and it did because this achieved two different things. And this is image 4. Number one, it used punch cards for repeated calculations.
Yeah.
So you see on the front of the machine there, and so we're still talking about we're talking about 1804, and we all know there were computer punch cards later in the 50s, 60s, right? But this was in 1804, and basically each one of these punch cards represented a step in this design process on this loom, right? Which I found fascinating. It was like
Crazy.
Yeah, so they use that to create repeated steps to create designs.
That is amazing, because I did not know until I was reading this pre-show that there was ever use of punch cards for computing or design work of any kind prior to the 1960s.
Right. And I when I read it, when I was doing the research on this, I was like, man, is that a typo? Punch cards? What are they talking about? 1804? No way. But there you go. I mean, somebody had a vision of, hey, you know, these little buttons need to drop in a certain order in order to perform a certain task. So they programmed those and created those and set them in sequence, and voila.
Well, like you say, the who's the genius? Is it the genius that built on the shoulders of people, or the genius that made it in the first place?
Exactly. And, you know, it's we all know that innovation is just as significant when it comes after an invention than, you know, just the invention itself. You know, creating something out of thin air is great, but there are a lot of people who couldn't vision anything, but they can take something that was created and they can make it 100 times better.
Right.
Yep. So the next device then was created by Charles Babbage, who was an English mathematician and inventor, and he also was a master machinist, and he created what was called the difference engine, and that is image number 5. So,
wow,
you know, this was able to return 20 to 30 digit results in calculations. And when you look at stuff like that, I mean, I'm starting to think of server rooms, you know, with huge server racks.
Well,
and
yeah. I mean, okay, so everything else that we've looked at before, even, you know, from the abacus to Pascal's machine and forward, you get up to around, you know, anywhere from 10 to 100,000, and you're maxing out the machine.
Right.
You're saying this thing will do quadrillions,
right,
or quintillions worth of numbers.
Yeah, 20 to 30 digit.
Wow.
Yeah. So it was really a turning point, and it would return. So some of the devices were more binary, 1 0 type of calculations, but this worked on the decimal 0 through 9. So it was able to return the exact result that didn't have to be ciphered or figured out, which was pretty amazing. And it mechanized not just a single calculation, but a whole series of calculations on a number of variables to solve a complex problem. And it went beyond calculators. Like modern computers, the difference engines also had storage.
Really?
Yeah, so it could take a data element, hold it temporarily, and then use it later in processing. So it basically could remember something and then bring it back.
Incredible.
Yeah, it's when I was going through all this, I mean, it was a pretty significant step, and I think actually the difference engine was a different device. The picture that I ended up getting was called the analytical engine, which was his next invention, and it was automatic, mechanical, and digital, and it could perform any calculation set. The idea behind what they were trying to accomplish was ultimately where they went with the IBM Mark One,
Okay.
which was, I'm sorry, the Harvard Mark One, which was they wanted to create. The goal was to create a device that could perform any calculation a human could.
Okay.
So any mathematical formula, any calculation, that's where initial early development was focused, was taking it and going ultimately to replace a human.
So making it more generalized, in other words, as opposed to specific. Hey, this can specifically add or subtract.
Add, subtract, multiply.
This can specifically multiply. This guy here is looking to generalize it, saying, I don't care what you need, I can do it.
Right. And so that was the thrust of what they were doing. And so they had, it was called the mill calculating unit, and it is analogous to what a CPU is today.
Okay.
And so we're still talking about the early 1800s, early to mid 1800s, right? Just crazy stuff. And then there was a reader and a printer where the input were input and output devices.
Right.
So just amazing stuff. And it could hold 1,000 50-digit numbers.
At the time, people are probably saying, what would you ever need something like this for?
Right.
Who would ever need to have 1,000 different 50-digit numbers stored anywhere for any purpose?
Right. And that's the thing. It's innovation usually follows before application. You know, there was no practical application when penicillin was discovered, yet they found practical applications for it. You look at the things that were developed that ended up being used in the space race, right? And there's inventions and discovery that we do as humans that has no practical application at first. You look at the particle colliders that have been built, and they don't know where they're going with that. They just know that they want to discover things, and then later other people come behind that research and find practical applications to it. So
yeah, I mean, a lot of times, like you said, penicillin it was an accident, or Post-it notes.
Right.
You know, they were trying to come up with, the 3M engineer was trying to come up with different types of adhesives, and came up with something that was too weak to be useful until it wasn't.
Right. Exactly. And that's the kind of the evolution of computers. It's there's a goal in mind. There's an objective in mind as far as what it can do from a base function set, but going to the next level and saying, okay, now I'm going to create an accounting package, or I'm going to create a machine that tracks the census, or I'm going to, do all this stuff is just, you kind of build the tools first, and then you let the tools build the application, right? And so with the invention of this difference engine, this analytical engine, we have our first computer programmer that came out of it. And that was Augusta Ada King, and she was known as the Countess of Lovelace, and she was the daughter of Lord Byron.
Oh.
And she learned how to program the sequencing of the instructions on punch cards to be able to make the machine work correctly. And in her own right, she was, a mathematician, but she's the world's first computer programmer.
Yeah, if we're going to call anything that's digital or analog that can do computations a computer, and a human who can produce a set of instructions, not just one at a time,
right,
and feed those instructions into the computer and have it follow those steps of instructions, that is programming a computer. That's what we call it.
Yeah, exactly. And it's it's interesting because when you make a product, when you make a device, then there are going to be people who develop those specialties, right? And so she was fascinated by Babbage and all of his inventions, and she plugged in and got significantly recognized because she was the first
Sure.
to understand what he was doing and to be able to really grasp it.
Well, and then don't anybody ever say that that females can't be as good as males.
Right.
It's not even the "anything you can do, I can do better" song like the ladies sing. She was first, man. She's the
Right.
best.
Exactly. That's a great song. So image 6, we bring this up. We're going to be talking about then at Columbia in New York, Herman Hollerith, and he worked this is a census counting machine. His professor was tasked, he had received a contract from the government regarding census tabulation. So he developed, Hollerith, who worked for, was it Trowbridge, his professor, he developed a machine to assist in counting the census. And so this was able to do automatic tabulation of statistical data. So it could track multiple data elements, not just one. Right. So we're not just adding up numbers now. We're basically creating records.
Right.
Yeah. And this would tabulate and calculate statistical data based on the numbers that it was fed by each category.
That is just as amazing as some of these others because there is complexity in volume.
Right.
I am infamously known amongst my family as a guy who cannot remember more than 3 things. So
I find that hard to believe.
So if my wife says, I need you to go to the grocery store, if there's more than 3 things on the list, I make her write it down because I know I'll forget something. And it's about the list itself is simple,
right?
But when you have many items on the list, same thing with the census,
right,
multiplied by what would be probably about 15 million or so,
right?
If you're looking at 5 data elements,
right?
But you're getting 15 million copies of 5 data elements, it's the 15 million that becomes really complex. That is such a cool invention.
Yeah. And what's the saying? Necessity is the mother of invention.
Oh, yes.
There's just, at some point, there's a bunch of bean counters in a room that get tired of putting tick marks in a column, right?
Yeah.
And there's got to be a better way.
Yeah.
And so the technology that came before created the vision of understanding that machines can be built to do this kind of stuff. So it was kind of interesting that it was tied to the census because that really is big data right there, kind of a first instance of a real world big data application for computing technology. So then we get to our next image, which is the Harvard Mark I. And that looks like a modern computer room. Oh, well, not modern, but
compared to what we've been seeing,
right?
Yes.
There's a lot there. I mean, there's a lot of computing power with that. And what they did was, this was built during World War II. They needed to. They built this on the back of Babbage's analytical engine, and this was increasing in sophistication as it grew. It went from Mark I to Mark IV, and they did all kinds of things with this computational technology. It could, if we look back at Babbage's stuff, and we're talking about 30, 40 digit numbers, 50 digit numbers, and this just built on that as the needs expanded. You look at all of the multi-data applications during World War II to be able to calculate materials and costs and things like that, components to construct all of the needs of war, as it were. Then you're looking at just big data.
This is one of the first of the room-sized computers, it looks like,
Yep.
because that is a massive room, and that computer takes the whole room.
It does.
I assume at this point it's working on electricity, although if we're talking World War II, the transistor had not yet been invented. We're all still vacuum tubes.
Right. Exactly. And speaking of vacuum tubes, so then we switch to the next image, which is Alan Turing. And everybody knows this from, if you watch The Imitation Game, this is how they broke Enigma, was using this device.
Right.
And on the back of that machine, in the movie you can see it, there are all these tubes and everything that provided circuitry, and the movie's great. If you haven't seen it, I would encourage people to watch it, because when you watch these dials move and it's figuring and calculating, and I'm thinking, what kind of brain thinks this up? This is insanity. This is so beyond where I could think. And you look at all the cabling, which
Yes.
we always see cabling, right?
That's right.
Because that's what we
right.
do. Then it could be, so they developed at that time what they called the effective method for problem solving, and that was where the standard was developed, that anything that could be calculated by a human needed to be able to be calculated by the machine.
Okay.
And this is how they got to the result that they were getting to, which was to break that code. So I would encourage anyone who hasn't watched that movie to watch it. And then the last segment last component of this segment, and there's no photo for it, but we're talking about computer networks, because computer networks are really important. And between 1940 and 1946, there were a couple of guys who Bell Laboratories built a series of machines using telephone technologies with electromagnetic relays. So that information would be electronically transmitted and run relays that would then perform calculations and provide the same, kind of shared data experience, right? And they were slow, because as we know, telephone technology up until relatively recently was all switched, right?
Right.
So it had to go through switching units, which made it incredibly slow to transmit those data elements. But we're all, familiar with by now the computer revolution of the last 50 years, and it's due in large part to all of the things that came before. And I just want to take time at the first segment here just to talk about the history and where it all came from, because, humans have this strong desire to explore and discover and develop and solve complex problems, whether it's technology or in other areas. We look at biology and all of the astrosciences and things like that. We are questioning, humans are questioning.
And like you pointed out already, the early ones were the innovators.
Right.
The ones that didn't know that there was a problem to solve necessarily, but they were doing things because they could, to see what could be done. And then you can see it yourself. You come back to the census machine or to the Mark I through Mark IVs. Now people have figured out, oh my gosh, these things are good enough to probably help us solve some of these big real world problems that we have.
Right.
And they do so.
Right. And you develop things without any practical application in mind, or maybe you do have an application for it, but it's your vision is tunnel vision, right? And so you look at things like, I need it for this narrow scope. But then even today, we see so many applications that get developed, whether it's apps for your phone or whatever, that get adapted to other uses.
Yes.
We in the medical community with drugs, they call those off-label uses, right? And so those are kind of the same thing, right? It's kind of off-label, but hey, I'm going to use this to do this, not just what it was built to do.
Well, it's almost like the people who discovered the aspirin. The Bear Company was they were doing processing, and a byproduct of their processing was this powder that people would grab handfuls of before they went home. And when the management went to the workers and said, "Why are you grabbing this handful of this waste stuff?" They said, "Well, it helps. I get tired and I get sore after I work, and if I take a little bit of the powder, it makes me not sore. It takes the pain away."
Wow.
And so within a few years, the management's smart enough to realize that they're onto something, and you've got Bear aspirin.
That's amazing. Yeah, it's so. Then there's countless stories, right? Of things that are unintentionally discovered.
Yeah.
And it's great. And so, in our technology world, we thrive on innovation. We thrive on that next hill to climb, or that next mountain to scale, right? So before we get too far into it, just want to remind everybody, please like, share, and subscribe to this podcast. We have it every week, Mondays at 10 a.m. Arizona time. And, we appreciate everybody that follows. And if you have comments, go ahead and shoot us questions in the comments, and we'd be happy to try to answer anything that you've got going on.
In fact, we have a comment that's come in this morning already, too.
We do.
Sam Manlate, hopefully I didn't butcher the name, says, "These podcasts are so educational. Thank you."
Oh, that's kind.
That's very kind.
Yeah, I appreciate that. And we're growing. I mean, we're not... So, Gruber Motors, up to 40,000 followers on YouTube. Yeah, that's the flagship. That's the battleship of the organization. But, I think we're over 300 now. So we're happy to come in, and we're a little late to the game. We just got going, and 8 weeks ago now? This is number 8.
381 actually, coming up on 400.
Coming up on 400. Yeah. We'd like to be at 400 after today then. Yeah.
The growth rate of the Wired Hour podcast is such that eventually this is going to take over the Power Hour, which is on Fridays at 10.
Wow.
And goes over Gruber Power Services. They just surpassed 1,000.
Wow.
And so this one's gonna overtake that one eventually, I think.
I hope so. I mean, I'm very competitive.
Of course.
we like the competition, because it's all it is good all the way around. So I know you're a guy who's been in computer tech for quite a while, and how many years? 30 years, 40 years?
Oh goodness, I have been. I started in high school in the 80s. So
okay.
I worked on one of the very first IBM PC clones.
Nice.
And learned how to do the GW Basic from Microsoft and MS-DOS. I didn't really work on version 1.0. I started out about 1.2 version.
Right.
But those were the days, I tell you.
I remember my first computer. Was one of those Radio Shack TRS 80s.
Yeah,
I think
the trash
it was.
80s.
Right. And it had a cassette tape recorder, which a lot of you will, it recorded the instruction set. So it was learning BASIC, and you'd have to record the instruction set on the tape, and then you'd have to play it back into the memory for it to work.
Right.
Yeah. You guys don't have it rough, let me tell you, especially anybody younger coming up and, getting into tech. You don't have it rough.
No,
the ground's been laid. You can be the visionaries. You can take it to the next level. But man,
and as I like to say, that telephone that you have in your pocket has thousands of times more computing power than the Mark I that we saw on the screen a few minutes ago.
Oh yeah, it's incredible where, so my dad, when we moved to Arizona, we moved here in 1968, and he was a computer systems analyst for GE. Okay, and the place he worked was right down 19th Avenue in Deer Valley here. That Honeywell facility right there. So back then it was GE, and then bought out by Honeywell. But that's where my dad worked. And I remember in the early 70s, he brought home it had a keyboard and it had suction cups, right?
Mm-hmm.
And he would dial the phone, plug it in to put the suction cups, because back then a phone had a handle and
Yep, you had
right?
your hand,
yeah.
your
So
handset.
they put it in there, and then he would start typing, and he would be working on computer printouts. And okay, so how hard is it to type something and not know what actually is being heard on the other end, right? There's no screen to give you any feedback and say, this is what it is.
Right.
So he was programming and, modifying code and doing all that. And then he would have to go into work the next day and get a printout to see what actually got into the code. And
oh man,
it was just sick stuff. I mean, even when I started at the bank, I started my career in banking. We had what we called a deck writer.
Yeah.
And we used it to run credit reports.
Yeah.
And you had to type in the sequences, and there was no screen, there was no feedback. Once you hit the button to display what you showed or what you typed, it would print it on the line. And if you screwed up, you had to re-input the data again and then print the line and make sure you got it right. So, and we're talking 80s, we're talking late 80s.
So a lot of people out here might not be familiar with the term WYSIWYG.
Yes. What you see is what you get.
There you go. That's and you don't even think about it nowadays, because that's automatically what you see is what you get. What you see on the screen is what you get on the paper.
Right.
And you get instant feedback. And even that, you can't take, people take that for granted nowadays. That's
right.
That's where computers have been.
Yeah. And I know there's a couple of guys talking about history and all that, but it's important, to know where things come from. It's so important to understand the foundations that have been laid, so that you can appreciate the tech. And what, throughout it all, consistently, there's been wiring. No matter what we talk about today, the cabling, wiring, fiber optics have been a linchpin of all the tech. When
Yes, they
we're
have.
talking about, whether we're talking about internal devices, and wires that communicate within the device or transmit electricity or whatever. But now with networking, all of this is all made possible by connectivity. And that connectivity is the backbone of that connectivity is wiring and fiber.
Absolutely. You can go back to that Mark I. There were the internal wires that helped to run the voltage and electricity between the components of the computer. And while I'm not I didn't do the research, I don't know exactly when, but at some point in the 1940s, 1950s, the idea came to people of, well, if I can do all of this with one computer, and it takes wiring to do this, why not run some wires from one of these computing devices to a second one, and I could double my capacity.
Right, exactly.
Because all I have to do then is talk to one another, and I've just doubled my computing capacity.
And so that is where ARPANET came in, right? That was really the first computer network. And so it was a precursor to the internet. And basically, it was set up by the U.S. Department of Defense. And it was, the desire to link communication platforms in order to make it happen.
Yeah, so much of what has been developed in our common lives today started out as a military application.
Sure.
And you're right, ARPANET is one of those. It was in military, and it was in the scientific community as well.
Right. Yeah. I mean, as far as the modern internet, at first it was wasn't it Stanford and was it UC Berkeley?
I think it was UC Berkeley and
right.
Stanford, yeah.
Where they can, the desire was because they had 3 different terminals for their 3 different computer networks, right? And the desire was to bring it all together into one network connection, right? So the pain caused the innovation of having to work on 3 different terminals. If I want to talk to this institution, I got to be on this one. If I want to talk to this institution, I got to be on this one, to combining it to one input output, and then doing what we now know is IP routing, right? Back then it was more switching, but one device being able to carry that over, so that it was one terminal actually doing the work.
Well, it's we call it TCP/IP.
Yeah.
They had just called it. Yeah, we needed to develop a protocol by which we can transmit data from computer to computer, and the one who's sending it will identify themselves, and they're going to identify where they want it to go, and then the one who receives it is listening for their address, almost like a street address,
right?
Except it's all numbers,
right? And it's all contained in a packet, and the packets get routed to where they're supposed to go.
Yeah.
And multiple packets, multiple locations, but one device. And you're right. So the TCP/IP, that protocol was developed in the 70s. And so were email protocols, and Ethernet, which is cabling that we produce, that was first conceived and invented in 1973, but standardization happened 10 years later. So just like with any technology, VHS versus Betamax, right?
Right.
There's got to be a standard. There was at one point there was a laser disc like this for videos as well, for movies, and
that's right.
Standardization needed to happen so that everybody just knew, I need this device, and everything that comes out is going to work on this device, right? And so that's kind of not putting Apple down at all. They've kind of relented on the messaging technology, haven't they? I think
they did.
Yeah, they kind of gave in, because and applause to Apple for giving in, because that takes a lot to just say, okay, this is the standard, and it's gonna mean that we're gonna communicate effectively across all platforms.
I do remember being in college talking about token ring versus Ethernet, and the whole idea that communication was not happening rapidly enough between computers,
right,
for people to so I'm thinking on my feet here.
Sure.
It wasn't happening rapidly enough between computers so people would notice the latency or the lag time from the time it took from one computer to get to another.
Right.
And the whole idea was, if computer A has a 200-foot connection to get to computer B, it might take a second or a second and a half to get a message across.
Right.
But if computer A, B, C, and D are all linked together in series, and computer A needs to talk to computer B, well, then you're only 5 feet away or something like that.
Right.
That was the idea behind a token ring. The inefficiency of the token ring, unfortunately, was if computer A wanted to talk to computer D, you had to go through 2 other computers first.
Gotcha.
They had to inspect the communication packet and then reject it and send it along the line. That might be okay for 4 computers, but it's not okay for 400.
Right. Right. And yeah, it's definitely impractical. I remember the only time I ever heard the term token ring was at a company I was at, where we had 3 IBM AS400s in a token ring environment, which meant that they talked as one basically out, right? And then, from there was switching and all that we were able to retrieve data.
Yeah. Some of the early PC networks were a little company in Tucson called Lantastic.
Yes, I remember them.
They were famous for their token ring networks, and but Novell and the Ethernet, the whole game changed when they figured out that central hub, that there could be a central hub of communication, and that central hub could itself if it were doing nothing but routing communication between the two right computers,
Yes.
it could suddenly become much more efficient. That plus the fact that communication speeds begin to go up. And instead of being your Cat 1,
10 or 1 megabit or 10.
1 megabit, you could go to category 3, which could get to 10 megabits.
Okay.
And suddenly communication was fast enough that you didn't notice the difference between 20 feet and 200 feet.
Right. Right.
And especially if there was some sort of switching mechanism, which we now call a network switch, that was helping to take the load off of the computers. Now your computers could be there to compute and not have to worry about communication nearly as much.
Right. So my first computer that I bought was a Packard Bell, and it was from Price Club, which was the precursor to Costco, and it was an 8086, not a 286, not a 386, it was an 086. And it could do one thing at a time.
Yep.
You know, you bring up a program, you can do it. I'm like, man, this is really inconvenient. Along came Windows. You know, eventually Windows took that multi-processing, you know, capability, which necessitated a higher need for communication. So you were doing dial-up, and you'd go from your 9600 baud modem to your 14.4 to ultimately 56K modem, and all of those pain points and all of that latency and all that waiting around brought us to the internet.
Yes.
Eventually. Because people want information now, they want speed now, they want everything instant, and so that's where things have come in that regard.
In the computer world, and I do think that there's an annual show in Las Vegas called the Comdex.
Okay.
And in the early 2000s, I was working for a consulting company, went to Comdex, and the keynote speaker explained how computers, at the time, computers were glorified calculators. And we're talking about late 1990s, so they can do a lot of stuff,
right?
But they were doing a lot of stuff on their own,
right?
Word processing, spreadsheets, database programs,
right?
That was pretty much kind of it. Oh, you would have video games and stuff a little bit, but that was very expensive to do on a computer, especially when you had something like a PlayStation or an Atari or a Sega Genesis or something like that that could do video games so much better than the computer could. And the keynote speaker came up and said, you know, in 10 years, these computers are going to be talking to each other. And you're going to see that your computer is going to become a Communication device, not a computation device.
Right.
Very prescient. That's exactly where things have gone in the last 20 years.
Well, you think, even conceptually speaking, you know, when I was growing up, we would call places. We wouldn't call people. We would call places.
Mm-hmm.
So you'd call somebody's home. You'd call somebody's work. Now we call people. So we have direct dial numbers to everybody, right? We're not calling them at a place. We're calling them where they are.
That's right.
And it's that kind of revolutionary thinking with computers is kind of the same. We basically want it to do anything we want it to do, and doing the, you know, word processing, emailing. When a family member would tell me, hey, you know, I want to buy a computer, I'm like, well, what are you going to use it for?
Mm-hmm.
Right? Because it matters what kind of computer you want depending on what you're going to do with it. And if you're just going to do, you know, Word and Excel, and back then it was
either DBase or Access.
Right. Quattro Pro.
Yeah.
And I learned over the weekend, because I had some product that I bought from Corel, that WordPerfect is still out there.
Oh, yes.
You know, it's heavily used by law firms, so I doubt it's going anywhere. But WordPerfect used to be the thing, right? Then Microsoft came out with Microsoft Works, which was a combined database and spreadsheet and word processing.
And it was terrible.
It was terrible.
It was terrible. I'm reading through our stuff and looking through the software, and I noticed that we went from Windows 3.0 to Windows 95, which integrated networking we're talking about,
Right.
to Windows XP.
Oh, you forgot the vaunted Windows ME.
Of course, and that stood.
Any-
It was supposed to be Millennium Edition, but
Yeah.
anybody who knew anything about computers said that is Windows miserable experience.
Yes. Look, only if you've fought in the trenches can you appreciate some of these references right now. Anybody who wanted to, they called it the bleeding edge of technology for a reason. Anytime something new came out, anytime something beta came out, I was on it.
Yeah.
And I learned new cuss words during all that, because it was just, you wonder how could somebody put something out that's so incredibly not.
Well, and it's the innovation of all this communication stuff that really, really built what we have here at Gruber.
Right.
Because you went from a 50 pair telco cable,
Right.
so you could have 25 lines in one cable, and that cable is about as thick as my thumb, to a 25 pin parallel cable, and so that's as thick as my finger, or when they got the later versions,
Right.
to a 9-pin serial cable, to a 4-pair 8 pins flat satin cable,
Right.
to to the
Cat cables. Yeah.
to the 4-pair category cables.
Yeah.
And the thing is, each introduction of new cable does not necessarily mean the old cable goes away.
Right. Right. There are people who still need Cat 5 cable
Absolutely.
right now, and we gladly produce that. We've got great solutions. And for those of you who don't know, we are on here talking about a lot of fun stuff, but we have a cable assembly shop in just across the yard here, and they build anything. Literally any cable, right?
They do.
So
They do.
we are very familiar with everything from all of the copper solutions, fiber. They build fiber assemblies. And by the way, check out our shorts on the channel as well, because that kind of Pete takes you through a lot of the different areas of Gruber Communications, and just their 10, 15, 20-second videos that show everything from the metal manufacturing that we do, all the way through polishing the ferrules on fiber, right? He runs the gamut. Pete does. He shows
he
everything.
does.
Yeah.
And and in fact, Sam Manlade had another comment for us a few minutes back. He says, your channel has so many great short videos that reveal and explain the cabling and manufacturing process.
Yes.
Says they're both educating and entertaining.
They do. And you know what it shows too, if I might be a little bold here, it shows that the company is real, and that we're not like reselling somebody else's stuff, right? Because anybody can say they do something, but these videos show what we manufacture, and they show the people behind it. It's a behind the scenes, real time look at Gruber Communications, Gruber Power, Gruber Motors. That's real people behind these products, and there's no shill going on here.
Right.
This is it's a transparent, open, here's who we are, here's what we do. 40 years in business, proud of it. We want, our customers to understand who we are and what we do. So,
well, in your 40 years, that makes, I wanted to add to that just a little bit, because, we've talked about some of these computer things. Do you realize that one of the most popular languages in computers on Earth today is COBOL?
really?
It
and
is.
my dad programmed in COBOL and Fortran.
Yes,
Yeah.
COBOL remains one of the most popular programming languages in existence today. A couple reasons. First, it's a highly structured language, so you had to be very specific in the way that you designed the language. That design methodology has not had to change a lot over the years because it worked.
Right.
And so, secondly, the banks picked up COBOL in the 1950s and 1960s. So your dad would have been programming COBOL almost definitely.
Yep.
Those banks don't want to reinvest and solve and have to resolve problems that have been solved for 30 or 40 years by throwing some new unproven language set.
Right.
So they still use COBOL, a computing language that is now almost 80 years old. In the same way, we still manufacture 50 pair telephone cables.
Right.
Everything over the last 40 years has gotten less as the older technology is being replaced, quote unquote, replaced by newer technology.
Right.
But you find in the cabling and infrastructure area the same thing. If something really works, when it wears out, companies would rather replace what works than have to tear everything out and try to build something brand new from scratch in a lot of cases.
It makes sense. You know, stability is important, especially in finance and the banking industry. And they are not looking to be innovators. They do not want to be on the bleeding edge, banks. You know, they want to make sure that their computer tech is solid.
Yeah.
And that kind of thing makes sense. Insurance companies are the same way, notoriously difficult to get to adopt, but not because it's bad what they're doing. They just don't need it. They don't need to adopt.
Yeah, they're risk averse.
Right.
And we have a lot of customers that take that to their hardware as well.
Right.
If they have an old phone system that requires 50 pair cables punched down to a 110 block out to analog phones, as long as they have somebody out there who's willing to support that phone system when it breaks, they're not going to change it.
Right.
And there are still companies out there that are supporting these 20, 30, and 40-year-old phone systems who then come to us to get those kind of cables.
There we go. And that's because we do everything. We do literally. I mean, if you look at the shorts and some of the when Pete goes into the custom cable area and he's showing some of that custom built stuff, I mean, come on. It's who's gonna do that for you? We are.
Well, yeah, it's Pete Gruber built a business on saying, I will do what other people can't.
Yep.
And we proudly continue that tradition today. We will do what other people can't. You give us a cable, and our fabulous manufacturing team will go in, reverse engineer that cable, give you, make the new cables for you up to at least the specification that the original cable had. And in almost all cases, we'll give you your original cable back.
Right.
As long as it's not like a plastic molded cable where they have to go through a destructive process to reverse engineer it.
Right.
And in most cases, if there's a cable that's specific enough that it needs reverse engineering, it's been built onshore in the United States and it has been built in such a way that it can be pulled apart and put back together.
It's one of the things that I have really enjoyed about being here at Gruber thus far is the can-do attitude and that type of desire to explore the different things that clients are doing, because we're not the answer on the phone usually is not a flat no. It's a we'll figure it out.
Yes.
You know, do we do something like that? You know, customer asks, can you do this? We might not specialize in something like that, but if you tell us what it needs to look like, we certainly can give you an estimate on what it would take for us to do it, because we're not going to say no. We're going to say, let us, work with you and find something. And I know one of the guys that I sit with in my little area over in sales, he just got done working on a project that it's a new machine that his customer is building, and there's all these cables that they need that were highly specialized, and he worked for months to get this thing to the final phase, and it happened last week, and now everything is, all the I's are dotted, T's are crossed, everything works the way, and now they have a resource for a very unique cable that doesn't go anywhere else. It goes in their machine and that's it. So that sort of thing is what makes me wake up every morning, right? I mean, I like that kind of stuff. It's really innovative. I mean, not to say that if you need a Cat 6A, I won't help, because we'll help at Gruber Sales. We want to give you any product you need, and know that it's build American, buy American. You last week we had our guy from Quabbin Cable on, gave a great talk. I mean, that guy is a wealth of knowledge in American-made cabling, and we proudly support that company. They supply us with great product, and we're able to build out cables that are solid and durable and exceed specs. They're great stuff.
Steve Spoons from Quabbin is a great guy. I've met him a couple of times as well, and wonderful. And you're right. While some of the things that we do for people and may not end up being in our wheelhouse, I happen to think of the story I heard from one of our old time salespeople who has since retired. I kid you not, he literally sold lumber to the U.S. Army and had it exported to Afghanistan while we were in Afghanistan.
Wow.
Definitely not a wheelhouse thing for us.
No.
But it was a can-do attitude.
Right.
He had a relationship with somebody who said, I don't know where to go right now. Maybe you can help. I know this is not your area of expertise, but see what you can do. But
I've totally had customers say, here's the bomb, bill of materials, here's everything I need. Find it all for me.
Yeah.
Okay.
And we can do that. Our specialty, of course, though, is the category cabling, is the fiber optic cabling. If it goes in your data center, it's going to be in our wheelhouse pretty much.
Exactly. And our metal fabrication is great. I mean, our server racks, shelving, cable management systems, you will not regret buying from Gruber. These products are amazing. We can customize them as well, so we can white label the product as well as send you Gruber brand. So our flexibility extends way beyond just producing something. We want to meet client specs. We want to be a partner with our clients, and your success is our success.
By all means, and because we do so much of our work as what we call make to order, we're not building something, putting it on a shelf, letting it sit there for days, weeks, months, or years.
Right.
We are actually working with the clients. That means that we will take a few days to turn something around where they might be able to go and buy a Chinese knockoff off the shelf. But the quality will be second to none. And it gives us the flexibility to do all these really specific requests. And when somebody comes to us and simply says, hey, I don't know how to get this, and you gave it to me and it looked great, but I have a last minute change. I hope that's okay.
Yeah.
We could say, oh, yeah, cool.
No problem. Yeah.
We'll make a tweak. And then, of course, with anything we build, you've got that lifetime warranty.
Absolutely.
And that's a stand behind our product type of warranty,
right,
where if something goes wrong, just come to us.
Peace of mind. They have peace of mind.
We don't care how long it's been. If your cable has become a failure point, get it back to us. We will fix it. We will replace it. We'll make sure you're taken care of.
100%. And it's great to be with a company that has that attitude. That I know we're kind of wrapping up on time here, so I'll save that story for next time. But I guess we're coming up on it. We want to wrap up.
Sure.
All right. And I am just want to make sure that you know that next week and every Monday we have the Gruber Wired Hour at 10 a.m. Arizona time. And we never change our clocks, so you have to make sure that set your clock to Arizona time. You'll always be right.
And there is a possibility that we're going to have a guest next week with you and John.
Okay.
A gentleman who works for a local sports team in town, and we'll be able to discuss some of what goes on behind the scenes there as well.
That'd be great. Well, we really appreciate you joining us today. That was a quick hour.
It went fast.
I mean, I looked up at the clock and it was like 10:40, and I'm like, no way.
Yeah.
So we really appreciate you being here today. And remember, we are here for you. So this isn't just, us sit here and talk for an hour. We are here for you. We want to serve our customers, and we want to have you as part of the Gruber team.
Thank you guys so much for being with us and sitting with us for this hour.
Like, subscribe, and share. And we will see you next Monday on the Gruber Wired Hour.
Take care.